Hello everyone. In today's session, we'll have a look at properties of multiplication of integers. Let's look at the first property, closure. In multiplication of integers, we have three situations. One, where both the numbers are positive. Second, where one of the numbers is negative and the other is positive. And the third is both the numbers are negative. Now, the situation one, which is both numbers are positive, is as good as situation for the whole numbers. And we know that whole numbers are closed under multiplication. So we will not look at situation one. So now let's look at the remaining two situations. Let's take one positive and one negative number, plus 5 and minus 3. So when we multiply plus 5 by minus 3, in the answer, first we multiply the weights. So 5 and 3, 15 is the multiplication of the weights. And for the sign, we look at how many negative numbers are there as multipliers. We have only one negative multiplier. One is odd, and odd always results into negative sign. So the answer is minus 15. Now here we can see that plus 5, minus 3, and minus 15. All the three numbers are integers. And hence we can say that in this case, integers are closed under multiplication. Now let's take this third situation which we wanted, that is both the numbers are negative numbers. So let's take minus 5 and minus 3. Now multiplying minus 5 by minus 3, we multiply the weight. So 5 into 3 is 15. And for the sign, we look at how many negative numbers are there in the multiplication. There are two negative numbers. 2 is even, and even results in positive sign. So now here the answer is plus 15. So the answer and the multiplier, which is minus 5, minus 3, and plus 15, all these three are integers, and hence we can confidently say that integers are closed under multiplication. So let's go and update our chart. We know that multiplication is closed in integers. Let's talk about commutative property. We know to check whether the integers are commutative under multiplication, what we need to do is to interchange the positions of the multipliers and see if the results remain same. Again, we are not going to check this situation where we have two positive integers, because that situation is already covered under whole numbers, and we know that in that situations multiplication is commutative. So let's take a situation where we have one positive number and one negative number. So let's multiply plus 5 with minus 3. What we get is 5 into 3 is 15. The multiplication of weights plus minus one negative sign gives result minus sign. Let's now interchange these positions, and let's do minus 3 multiplied by plus 5. So that is equal to, again we have to first multiply the weights. So multiplication of weights gives 3 into 5, 15. Again, only one minus sign in the multipliers. That means the final sign is minus. So now we see here that even if we change the position of the integer, the result remains same. Let's see the third situation. Let's take two negative integers, minus 5, minus 3. First, let's multiply minus 5 by minus 3. Multiplication, we need to multiply the weights. 5 into 3, 15. Two minus signs, even number of minus signs means the result is plus 15. Now we change the position, we do minus 3 multiplied by minus 5. That gives again multiplication of weights, 3 5s are 15, two negative numbers, even number of negative numbers means the result is positive. And now in this case also we see that both the results are same even after changing the position of the integers, and hence now we can say that multiplication is commutative in integers. So let's go and update our chart. Multiplication is commutative under integers. Now let's talk about the associative property. In associative property, we see whether the change of order of operation results into same result. If it happens, then we say that that operation is associative. So let's take three integers, -5, +3, and -4. Now first let's do -5 into +3. So first let's do this and then multiply it with -4. And in the second case, what we'll do is we'll do -5 into +3 multiplied by -4. So we'll do this first. So first we are going to multiply -5 and +3, and in the second situation we are going to multiply +3 and -4 first. Let's do this side. So 5 and 3 weights, multiplication of weights gives us 15. Only one negative integer, which means it's an odd number of integer, odd number of negative integers gives us negative sign, multiplied by -4. So now again multiply the weights. 15 fours are 60. Two negative integers will result into a positive sign because they are even number of negative integers. Now let's do on this side. First, let's keep -5 as it is, and let's do the calculation here first. 3 into 4 weights, 3 into 4 12. Sign only one negative number, odd number of negative numbers gives minus sign. Now in this case, -5 -12, let's multiply the weights. 12 5s are 60. Now here two negative integers, which is even number of negative integers, gives sign +60. And now we can see here clearly that both sides the result is same, it does not change, and hence we can say that multiplication is associative in integers. Let's update our chart. We know multiplication is associative in integers. In multiplicative identity, we want to know a number which when multiplied does not change the original number. For example, if I have -5, which number I should multiply so that I get the answer also as -5. Now we know in integers the answer is same as multiplication of weights of the multipliers. So now the answer is 5 and one of the multipliers is 5, so which means the second multiplier has to be 1. Then only the multiplication of the weights will remain 5. Now let's look at the sign. The answer sign is minus, which means that on the multiplier side we need to have odd number of negative integers, and we already have 1 -5, so the second integer will not have the negative sign, so it has to be plus sign, so it is +1. Let's take another example. We have 13 multiplied by something should be equal to 13. Now what happens here? The multiplication of the weights of the multiplier should equal to the result. So 13 multiplied by something should be equal to 13, and so 13 multiplied by 1 is 13. Now regarding the sign of the result is plus, because there is no sign which it is a positive sign. So if it is a positive number, we need to have even number of negative numbers or no negative numbers. Now 13 is positive, so we cannot have 1 as negative. 1 also has to be positive, and hence what we can say is 1 is our multiplicative identity. Let's update the chart. So multiplicative identity for integers is +1. Let's now see what happens if we multiply by 0. So we want to see what is the result if we multiply any integer by 0. Let's take example. 3 multiplied by 5 is equal to 15. 2 multiplied by 5 is equal to 10. 1 multiplied by 5 is equal to 5. So here we see that we are changing the multiplier, or we are reducing the multiplier by 1. So we are doing -1 every time. And we see here that the answer changes by -5. Now, what will happen when we change from 1 to 0? The answer has to change from 5 minus 5. 5 minus 5 is 0. So if we see here, the answer also changes by -5 as we change the multiplier by -1. So 0 multiplied by 5 will give 0. That's true for the positive integer. Let's look at the situation for the negative integer. Let's take negative integer. So 3 multiplied by -5 is equal to -15. 2 multiplied by -5 is equal to -10. 1 multiplied by -5 is equal to -5. So what is happening here is I am reducing the multiplier by 1. I am reducing it by 1, and here for the answer what is happening is the answer is increasing by 5. So it is becoming +5. So what would happen if I reduce the multiplier further by 1? The answer has to be increasing by further by 5. Correct? So let's see what happens. So from 1 minus 1 is 0. So 0 into -5 is equal to -5 plus 5. -5 plus 5 is 0. So whenever we multiply any integer, now in this case +5 we multiply by 0. In this case -5 we multiply by 0. But in both the cases, the answer what we get is 0. So multiplication of any integer by 0 gives us 0 as the answer. Let's update our chart. Multiplication by 0 is always equal to 0. Let's now solve a few examples using multiplication properties. One example from 1.3, and it says find the product using suitable properties. 8 multiplied by 53 multiplied by -125. Now, before I solve this example, I'm going to give you some tips here. Now, whenever you see any of these numbers, okay, whenever you see any of these numbers, 25 in your multiplication, look out for a 4 in that multiplication. Look out for a 4 so that 25 multiplied by 4 is equal to 100. And once you get 100, multiplying any number by 100 becomes easier. Same way, when you see 125, look out for 8, because 125 into 8 is 1000. Now, 125 has some more multiples which are also important. For example, 375, because 375 is equal to 125 into 3. Same way, 625. 625 also is equal to 125 into 5 or 875. 875 is equal to 125 into 7. So whenever you see any of these integers 25, 125, 375, 625, 875, please try to locate the associated integer. For example, for 25, look for 4. For 125, look for 8. For 375, 625, and 875, which are multiples of 125, again, look out for 8. So now here we see that there is 8 and there is 125. Now, but they are far away. Now, normally, as per board mass, what we'll have to do is we'll have to first multiply 8 by 53, and then whatever is the result, we have to multiply to 125. But we will be using the commutative property and we will change this. So instead of this 8 into 253, we'll use the commutative property and we'll make this 53 into 8. So what we have done is we have used commutative property. Commutative property. Now, using the associative property, instead of doing 53 into 8 first, what we are going to do is we are going to do this multiplication first. And we know that associative property allows us to change the order of multiplication. Hence, what we are going to do is keep the 53 as it is and multiply 8 into 125. Now, 8 into 125, we know the multiplication of the weights is 1000. And about sign, 8 is positive sign, 125 is negative sign. Only one negative sign, which is odd number of negative signs, the answer gets negative sign. Now, it is easy multiplying the weights of these two numbers, 53 and 1000. It is going to be 53,000. And for sign, again, we look out. There is only one negative number, which is odd number of negative numbers. Odd number of negative numbers gives negative sign for the result. And hence, the answer is 53,000 minus negative 53,000. Let's solve one more example. 15 multiplied by minus 25 multiplied by minus 4 multiplied by minus 10. Now, as I told you, when you see 25, look out for 4. Now we do have them side by side. Now, using the associative property, what we are going to do is, instead of multiplying 15 and minus 25 first, we are going to multiply minus 25 and minus 4 first. So 15 remains as it is into minus 25 into minus 4. Let's multiply the weights. 25 into 4 gives us 100, and minus two negative numbers, that is even number of negative numbers. Even number of negative numbers gives positive sign to the answer. So plus 100 multiplied by minus 10. And now we can multiply 15 into 100 is 1500. Both signs positive, no negative sign, so answer is positive, multiplied by minus 10. Here again, multiplication of weights, 1500 into 10 gives us 15,000. One negative number, which is odd number of negative numbers, gives minus sign. So minus 1500 is our answer. Let's take one more example. Let's take 375 multiplied by 13 multiplied by minus 16. Now, as I told you, whenever you see these numbers 125, 375, 875, these numbers, when you see, you need to know that there has to be a 8 there. So look out for 8. Do I see a 8 in 13? No. Do I see a 8 in minus 16? Yes, there is a 8 in minus 16. So we'll just do this one step extra. 375 multiplied by 13 multiplied by 8 multiplied by minus 2, because we know that 8 multiplied by minus 2 is equal to minus 16. So we have factorized minus 16 as 8 into minus 2. Now we will use the commutative property. Using the commutative property, we will physically move the number. So 375 into 13, we will make it 13 into 375. That is, we bring the 375 and 8 close to each other. We'll also factorize 375 as 3 into 125. So you can see what we have done. We have factorized here and we have factorized this as these, and we have brought 125 and 8 close to each other. So that now can be solved easily. Is equal to, we will use the associative property and we'll solve 125 into 8 first. So 13 threes are 39 into 125 8s are 1000 into minus 2. Okay, so that gives us 39,000. 39 into 1000 gives 39,000 into minus 2, which is 39,000 into 2 is 78,000. And sign, there is only one negative number, one is odd, so the result is minus. So minus 78,000. Now what we have done here is we have seen that there is a 375. So 375 we have factorized into 3 and 125, and we also saw there is a minus 16 which we have factorized as 8 and minus 2. That way we have got two numbers, 125 and 8, which makes all our calculations easy, because 125 into 8 gives us 1000. The remaining 13 into 3, 39 is easy multiplication, and then again 39 into 2, 78, and further multiplications are easy. Let's now look at distributive property. We have seen the distributive property when we were learning the whole numbers, and the distributive property was shown as A multiplied by B plus C is equal to A into B plus A into C. So if we have three whole numbers A, B and C, okay, then they are distributive over addition in such a way that A is multiplied to the addition of B plus C is same as A multiplied by B only plus A multiplied by C only. Now let's see if this applies to the integers. So let's take integers. A is equal to -1, B is equal to -2, and C is equal to 3. And let's see if this is true. Now let's solve the left hand side first. So LHS is equal to A multiplied by B plus C. Where now replace the values of A. A is -1 multiplied by B. B is -2 plus 3. C is plus 3. That gives me -1 as it is. Let's solve the bracket first. So this is -2 plus consecutive signs, equal signs gives us positive. So plus 3. Now -2 plus 3. Different signs means it is subtraction. So we subtract 3 minus 2 is equal to 1, and hence it becomes -1 into bracket 1, and 1 gets the sign of greater integer or greater number, which is 3 here, and the sign is plus. So plus 1. Now -1 into +1. -1 into +1, multiplication of the weights gives us 1, and only one negative integer, which is odd number of negative integers, gives the sign as minus. So our answer is -1. Now let's solve the right hand side. So for right hand side, is equal to A into B plus A into C. So A is -1 into B is -2. Let's put a bracket around them. Plus A is again -1 and C is +3. Let's put this second bracket around it. So now here -1 into -2. Let's first multiply the weights. 1 into 2 gives 2. 2 negative numbers here. So even number of negative numbers gives answer as plus. So it's +2 for this side, plus here -1 into 3, multiply 1 and 3 gives us 3. Only one negative integer, that is odd number of negative integers, gives the sign as negative, -3. Solving this, +2 plus and minus, resultant sign, different signs gives the resultant sign as -3. +2 -3, different signs means it is subtraction. So 3 minus 2 is equal to 1. The answer is 1, and answer gets sign of greater number, which is 3 in this case, and the sign is minus. So the answer is minus. And now we can see that in this case, the left hand side and right hand side, they are equal. Hence, we can say the distributive property holds true for integers as well. Now we have seen this distributive property over addition. We can also use the distributive property over subtraction, and the distributive property over subtraction is also written as A into B minus C is same as A into B minus A into C. So if you see here, what's happening is this A first multiplies with B and this A then multiplies with C, and in between, the sign in between B and C is also carried over here. So here A multiplied by B, A multiplied by B, then there is a plus sign in between. So A, when it is moving from B to C, there is a plus sign in it. So he takes the plus sign here, and then A multiplies by C. So here A multiplied by B, A multiplied by B comes. While moving from B to C, there is a minus sign, so that minus sign comes here, and then A multiplied by C, A multiplied by C. It is very important that we are able to see the distributive property from both sides. Let me tell you what it means. So we saw distributive property as A multiplied by B plus C is equal to A into B plus A into C. So this is, we are looking for a property from the left hand side. So left hand side is A into B plus C. Now let's interchange the sides. So now it will become A into B plus A into C is equal to A multiplied by B plus C. So many times you will also need to use this way, the distributive property. So in this case, what we are saying is that we have two multiplications and in between there is an addition, and we see that in these two multiplications, number A is common between them. So we can take that common number out. We can take the common number out and we can multiply inside that. Whatever is remaining between A into B, B is remaining. And whatever is remaining between A into C, C is remaining. And what's the sign between them? Plus. So it will say remaining is B plus remaining is C. So A into B plus A into C is same as A into B plus C. And let me tell you that while solving the examples, we need both these forms of distributive property. Let's solve a few examples from exercise 1.35. So let me take the first example. 26 multiplied by -48 plus -48 multiplied by -36. Now, when we see this example, what we observe that there are two types of operations. There is multiplication and there is also addition. There are two types of operations. Whenever we see two types of operation, think about distributive property. Think about distributive property. Now, what you need to find is, do you see a common number in both these multiplications? So first multiplication is 26 into minus 48. And the second multiplication is minus 48 into minus 36. Now we see that minus 48 is common between them. And hence, using distributive property, we will take the common out. So I'll put minus 48 common as out. And then I'll multiply, and in bracket, I will put from this side multiplication 26 into minus 48 is come out. So what is remaining? 26. So the 26 stays here. I'll keep sign plus. No sign for 26 means it is plus sign. I'll keep the plus sign. Then while moving to the next multiplication, in between we get a plus sign. So that plus sign stays here. Plus, what is common in these two multipliers? Minus 48 has come out as a common. So remaining is minus 36. So plus minus 36. So this is what we have used is, we have used distributive property. And what we have used is the second representation of the distributive property, where we are taking out the common. Okay. Now this we solve. Minus 48 stays as it is. In multiplication, we solve the bracket first. It is plus 26 plus minus resultant sign, because they are different signs. Resultant sign is minus. So plus 26 minus 36. Now 48 remains as it is. Inside bracket, plus 26 minus 36. It is a different signs, means subtraction. So subtraction, we'll do it in the rough area. 36 minus 26 is equal to 10. So 10, we bring it back here. And what is the sign of this answer? Sign will be sign of the greater number. Between 26, 36, 36 is a greater number and its sign is minus. So we'll use minus 10 here. Now multiplication, one more negative number, second also negative number. First, we'll multiply the weights. 48 into 10 gives us 480. Two negative numbers, even number of negative numbers gives the answer sign as plus. 480 is the answer. Minus 17 into minus 29. Now, when you have asked to solve this product using a suitable property, do not directly multiply 29 and 17. Use the suitable property. Now, which property we need to use? We need to use the distributive property. Now, how I understand that this is a distributive property? Because minus 29, I can convert it into a different number. How? I'll keep minus 17 as it is, multiplied by, instead of minus 29, I will write minus 30 plus 1. Is minus 30 plus 1 equal to minus 29? Yes, it is. And by doing this, now I can use the distributive property. So this is A and this is B plus C. So A into B. So minus 17 multiplied by minus 30. And then while going to the next number, which is a sign in between, plus. So plus remains here. Minus 17 multiplied by 1. Now solving this, 17 into 30. 17 into 30, 17 threes are 51, so 510. Now two negative numbers, even number of negative numbers gives answer as positive, plus 510. Plus here remains as it is, minus 17 into 1. What is the sum of their weights? 17 into 1 is 17. Only one negative number here, so odd number of negative numbers gives answer as minus 17. Now plus 5, 1, 0, and this plus minus successive signs are different signs, so resultant sign is negative, minus 17. Now again, plus minus different signs means subtraction. So we'll do subtraction in rough area, not in main area. So 510 subtracted by 17 gives me 493. So answer is 493. Now answer has to get sign of the greater number. Greater number here is 510 and its sign is plus. So the answer is plus 493. Now it is very important here to spot this, where minus 29 can be represented as minus 30 into 1. And because the moment we get minus 30, multiplying minus 30 with 17 becomes very easy, because it is just 17 threes are and then 1 0. So that is what is very important, to see which number will make my calculations easy. Let's take one more example. Minus 41 into 102. Now in this case, multiplying by 102 is difficult, but can I convert 102 into 100 plus 2? Yes, I can. So we'll do 41 into 100 plus 2. And now I'll use, using distributive property, minus 41 into 100. So minus 41 into 100 here. Now I have to go to next number, but while going next number, I get a plus sign in between. So I'll write that plus sign, and then I will do minus 41 into 2. Okay. So now solving them, minus 41 into 100 is 41 into 100 is 4100, and sign is minus because there are odd number of negative numbers here. Plus minus 41 into 2, 41 twos are 82. And again, only single negative number gives minus sign to this. So now rationalizing the signs, plus minus different signs result into minus 82. Minus 4100 minus 82. Both signs are minus. Same sign always result into addition. So the addition is 4182. And this gets the sign of greater number. Greater number is 4100. Its sign is minus. So answer is minus. So the answer to this is minus 4182. Let's solve one more. Minus 57 into minus 19 plus 57. I observe that this sum has two operations, a multiplication and an addition. Whenever I see two operations, I should think about distributive property, but the second representation of the distributive property. So I need to find a common between them. Now minus 57 and plus 57, I see 57 as common, but here it's minus 57. So I am able to change this 57 as minus 57 into minus 19 plus, in bracket, minus 57 into minus 1. Plus 57 can be also represented as minus 57 into minus 1, because product of their weights is 57 into 1 is 57. Two minus signs result into plus, so plus 57. Now I can easily see that minus 57 is common. So I'll take minus 57 as common, and inside my bracket, from this multiplication, what is remaining is minus 19. While going to the next one, in between I get plus sign, so I'll write that plus sign here. And then from minus 57, what is remaining here? Minus 57 into minus 1, minus 1. So minus 1. So that is equal to minus 57, and inside the bracket minus 19 plus minus two successive signs which are different gets a resultant sign as minus 1, which is equal to minus 57 minus result into addition. So 19 plus 1 is 20, and the 20 comes with sign of greater integer, which is minus 19, and hence minus sign. So minus 57 multiplied by minus 20. Let's multiply the weights. 57 twos are 114 and 0, 1140 is the answer of the weights multiplication. Signs, I see minus here, 2 minus signs means even number of minus signs result into plus. So answer is plus 1140.